Okay, so this is term 1, week 2, term 2, week 2, math CA. There's integration and there's areas. Okay, is there volumes? No volumes. Okay, very, very easy. Okay, I'm gonna start with question 1, very easy. Integral. Integral, when you have a product, you need to expand. You're not allowed to keep it like this. Expand x squared plus 1, x plus 2, x squared times x is x cubed, x squared times 2 is 2x squared. Okay, 1 times x is x, 1 times 2 is 2. So now you have integral of this dx. Integrate. Integrate x cubed, you get x4 over 4. Integrate to x squared, you get 2x cubed over 3. Integrate x, you get x squared over 2. And integrate 2, you get 2x. And of course, since it's an indefinite integral, you have to put plus c. Okay, this is your answer. Very easy. Okay. Question 2. Integral here again, same thing. You have a quotient, so you split it up. 2x over x to the power 4 is actually 2 over x cubed, because the x up cancels with the 4, so you're gonna be left with 3, right? So 2 over x cubed. And then 5x squared over x to the power 4. The x squared cancels with the x4, so it's gonna be x squared down, because 2 minus 4 is 2. Okay, so you're gonna have plus 5 over x squared dx, right? Integral. Type, you can't leave the x down, so it's gonna be 2x minus 3 plus 5x minus 2 dx, and integrate. 2 down, x down. Add 1 comes minus 2, divide by your new power. 5 down, x down. Add 1, minus 1. Divide by your new power plus c. 2 over minus 2 cancel. You're going to be left with minus x to the power of minus 2. 5 over minus 1 becomes minus 5 x to the power of minus 1 plus c. And then obviously if you want to take them down to make your power positive, it's going to become minus 5 over x minus 1 over x squared plus c. Okay. Question 3. Okay. Find the area of a curve. Okay. Basically, I'm not going to waste too much time explaining, but anytime you have your graph and you have a curve, whatever, this is okay. This is not a function, but for whatever. If you want to find the shaded region, if it's a curve, you need to find the area. But basically, we're used to finding areas as in like, oh, it's a triangle. You just do base times height over 2. So here's the thing. What mathematicians did is they split this up into small rectangles, okay? And as they kept on zooming in and in and in, you would start to see this, like, you would kind of cover these small curved areas, okay? So basically, there was a lot of yap, but they decided, oh, we can just keep on finding areas of rectangles and just making the rectangle smaller and smaller, and then you're gonna get basically the area. But to do that, they invented the integral, okay? The integral is used to find the area of a curve, okay? I'm not going to waste too much time explaining, but when you add up all these small rectangles, you're going to get integral. How do you find the area? Let's say I'm going from 0 till, I don't know, 5. So your integral will be a definite integral with bounds 0 to 5, and then your function. Let's say this is, I don't know, sine x, okay? Then here you're going to have sine x dx. I used a very bad example. You guys don't know how to integrate sine x, but that's not my point. My point is you put any function under the integral. Over here, the region bounded... Okay, yeah, I also forgot to say something. When you're finding areas, you understand you use the integral, right? Type, let's say this is when you're finding the area with respect to the x-axis. So let's say, I don't know, this is x cubed minus 4x squared. Okay, we're going to do integral 0 until, let's say, 5. X cubed minus 4x squared. And what are we integrating with respect to? Dx. When you see this, I'm basically telling you I'm finding the area between bounds 0 and 5, x equals 0 and x equals 5. For those of you who don't know, x equals 0 is a vertical line. Okay, so it's basically between here, 0, and x equals 5. This vertical line up here. So we're basically finding the shaded region here. Between what and what? Am I finding this shaded region up here? No. We're saying dx. So with respect to the x-axis, so in between the curve and the x-axis, okay? Here, same thing. Some people say, oh, since it's below the x-axis, the area is going to be negative. Never. Area and volume will never, ever be negative. But if it's in the case of like mechanics, remember we used to say, oh, if it's below the graph, so you're going to use the height as negative 10 and whatever, you're going to get a negative area. That's for the case of something else, okay? Thank you, Jamil Ahmed Khan, for this one. But basically, here in math, it has to be positive, okay? You get a negative answer by accident, make it positive. It was said in the book, okay? Anyway, so this is how you find the shaded region. Sometimes they're going to ask you find the shaded region between the curve and the y-axis. I don't know if it's here though. If we reach it, I'll explain it. Okay, let's say instead of between the x-axis, they said between between our curve here and the line y equals 2. Okay, so between these two lines. Okay, so we would want this shaded region. Same exact thing, integral from 0 to 5, except now we have two functions, these two, right? طيب, how do we do it? Anytime you have two functions, you just subtract. So you write x cubed minus 4x squared, and then you put minus 2. That's it. Okay, anytime you have more than one function, you just subtract them. Okay, طيب, let's see. The region bounded by y equals x minus x squared over 2. So x minus x squared over 2. Why is my pen like this? I need to zoom out, I think. Y is equal. Okay, y is equal to x minus x squared over 2. Okay, in between 0 and 3, these are the bounds. Okay, it's shaded below. If its area is expressed as k over 3, then what whole number is equal to k? Let's take a look. Whenever you have it going into the negative side, you split it up alone. So over here, and I want the area from 0 to 3, صح? So what many students will do, and it's a very big mistake, is just take from integral 0 to 3, x minus x squared over 2. Wrong. Completely wrong. If you have a negative, you split it up, you solve it by itself. So we're going to solve first the positive values. So from 0 to 2. So integral 0 to, our curve is x minus x squared over 2. For the sake of making our lives easier, let's simplify this so I actually am able to write it. So we have x over 2 minus x squared over 2. So we can integrate properly, okay? So we have x over 2 minus x squared over 2. dx. Let's integrate. X over 2. You take the x down. It was x power 1 becomes x squared. Okay? It had over 2 already, right? It had over 2. Okay? You divide by the new power again over 2. Well, you know, I solved this really shitty. Let me say this again. To integrate x over 2, you have the over 2, you're going to take it to the side. Okay, remember, you always drag the coefficient down. If it's over 2, you just drag 1 over 2 to the side. Right? X, you add a power, so it becomes squared. Divide by the new power over 2. Right? Oh, shit. Over 2. Minus x squared over 2. Again, drag the coefficient outside. So drag minus 1 over 2 outside. X, take it down, add 1 to the power over the new power. Okay, there's no plus c since we're integrating with bounds. This is the integral. Okay, we're gonna keep this now here because we're gonna reuse it later for the 2 3. Okay, what are our bounds? 0 and 2. Very easy. Simplify a bit. 1 over 2 times x squared over 2 is actually x squared over 4. Minus 1 over 2 times 1 over 3 is minus x cubed over 6. Between 0 and 2. You take your calculator. Okay, we're gonna do, it's a lot of writing. We substitute 2 first, right? 2 squared over 4 minus 2 cubed over 6, right? This is the first one. You always subtract between the bounds. Minus 0 squared is going to be 0. 0 cubed is going to be 0, so I'm just going to put 0. Okay, let's do this on a calculator. 2 squared over 4 minus 2 cubed over 6. You're going to get minus 1 over 3. Remember, if it's a negative value, what do? You make it positive. So we're going to get 1 over 3 for the first part. So over here, this is 1 over 3. Now we need to find this upside down part. So we're going to integrate with bounds 2 and 3, right? Same integral. I'm not going to integrate again since we already found the integral, right? We already found it as x squared over 4 minus x cubed over 6. So now I'm just going to reuse it. But my bounds are from 2 to 3. So we're going to take 3. So it's going to be 3 squared over 4 minus 3 cubed over 6 minus, now substitute 2. 2 squared over 4 minus 2 cubed over 6. Let's check. I think it's going to be, let's see, 3 squared over 4. I feel like I did something wrong. That's why. Minus 3 cubed over 6 minus, into our bracket open, 2 squared over 4 minus 2 cubed over 6. Oh, okay. I made a mistake. Basically, I'm gonna redo the question, but we did everything correct except one part, but it's all the way at the start, so I'm just gonna redo it, okay? Over here, when I read the equation, x minus x squared over 2, the over 2 is only for the x squared. So unless they say x minus x squared in brackets over 2, then it's just x squared. Okay, so it's going to be x minus x squared over 2 as an integral. Okay, we're integrating with bounds 0 to 3 dx. Oh, let's integrate. Oh, what is my Steam opening? integrating from 0 to 3. But let's first find the integral and then we split up the bounds and whatever. Integrate this, x becomes x squared over 2, x squared over 2, take the minus 1 over 2 to the side, take the x down, increase the power, divide by the power. So the integral is going to be x squared over 2 minus x cubed over 6, right? What are my bounds? I'm first going to integrate from 0 to 2, the positive part, صح? And then I'm going to add from 2 to 3. So first, let's find from 0 to 2. From 0 to 2, it's going to be 2 squared over 2 minus 2 cubed over 6, which is going to be equal to 2 over 3 if you do it on a calculator. Okay? Now, from 2 to 3, we need to find command x squared over 2 minus x cubed over 6 from 2 to 3. Let's do it now from 2 to 3. You should get a negative answer here. You should. If you don't, I don't know, maybe you did something else. Substitute the 3. Now, minus, open bracket, and substitute 2. Remember, when you have bounds, you're subtracting both bounds. Okay, so 2 squared over 2 minus 2 cubed over 6. Okay, let's do it. 3 squared over 2 minus 3 cubed over 6 minus, open the bracket, 2 squared over 2 squared over 2 minus 2 cubed over 6. You get minus 2 over 3. Remember, you get a negative. What do we do to it? We make it positive. Okay, so 2 over 3. So you have 2 over 3 here, 2 over 3 here. Add them, what do you get? 4 over 3. So k is equal to 4. Okay. Question 4. Okay, the area of the region enclosed by y equals x squared and y equals minus 5x plus 6 is k over 6. Remember, whenever you have two curves, you just subtract them. So it's going to be integral. Okay, x squared minus, since it's an equation, you have to put the minus into the whole equation. Not just put minus 5x plus 6. No, minus into minus 5x plus 6. Okay, dx. Some people here, they're going to say, okay, Walid, that's cool, I will integrate, but what are my bounds? Here's the thing. You need to figure out the bounds on yourself. Whenever you have two curves and they don't give you your bounds, you need to find yourself. And how do you do it? You just equate them. You need to see where do they intersect. So x squared equated to minus 5x plus 6. And you should easily be able to solve this. It's a quadratic. So you take everything to one side. It's going to be plus 5x minus 6 equals 0. Okay. Which two numbers multiply to get 6? You can use the quadratic formula as I factor to multiply to get 6, but subtract to get 5. 1 and 6. So 6 and 1. It's a minus, so the plus goes here, the minus goes here. So you get two solutions, negative 6 and 1. So your bounds will be negative 6 and 1. Some people will be scared. They'll be like, whoa, how do I know if I have to split it up? See here, y equals x squared. You know for a fact it's never negative, because I'm sure you guys know y equals x squared looks like this. It's a parabola. Oh, it's a quadratic, so it's squared. It's always going to be positive. Okay, so let's integrate this now. I will distribute the minus. It's going to be x squared plus 5x minus 6 dx. Integrate is going to be x cubed over 3 plus 5x squared over 2. I'm going to go fast a bit with integration because I don't want to waste time. You should know how to integrate from minus 6 and 1. Now, put your bounds. 1 cubed plus over 3 plus 5 into 1 squared over 2 minus 6 times 1 minus, open bracket. Now substitute minus 6 cubed over 3 plus 5 times minus 6 squared over 2. Minus 6 times minus 6. Please make sure to put the minus 6 under the bracket. Okay, let's put this in our calculator. 1 cube over 3 plus 5 times 1 square. 1 square is just 1. Oh, it's just 1. So I'm not gonna write it. Okay, over 2 minus 6 times 1, and then minus, open bracket, minus 6 cube. Remember, put it in brackets. 6 cube over 3 plus 5 times minus 6 squared over 2 minus 6 times minus 6. We should get minus 343 over 6. Remember, we make it positive, so you get 343 over 6. Okay, so k is going to be what? 343. Okay, moving on. Question 5. How many questions do we have? Whoa, that's a lot of questions. Let me speed it up. Okay, integral from 2 to 4 to x plus 6. I'm going to do this very, very fast. I'm not going to substitute on yourself. Integrate. 2x becomes 2x squared over 2. 6 becomes 6x. What are your bounds? 2 to 4. So substitute 4 and then substitute 2 and subtract them both. Okay, you should know how to do it. Question 6. Integral 10 dx, same thing. 10 becomes 10x, and your bounds are 2 and 5. Okay, so substitute 5, then substitute 2, and then subtract them both. Question 7. The area enclosed by the curve 3x squared plus 2x plus 4, the x-axis and the lines x equals 1 and x equals 2 is something square units. Here, they gave you the curve, they gave you the x-axis, and they gave you x equals 1 and x equals 2. When we say lines x equals 1, x equals 2, that means they gave you your bound. So between here, x equals 1 and x equals 2, that's your bound. Okay? So let's see here, 3x squared plus 2x plus 4, the x-axis. What do? We integrate. Our bounds are 1 and 2. Integral of 3x squared plus 2x plus 4. Integrate this. Take 3 down, increase power of x, divide by new power. 2, increase power, divide by new power. 4, add an x. Okay, bounds are, what are my bounds? 1 and 2. Okay, this cancels with this cancels with this, make our life way easier. Substitute now 2, so it's going to be 2 cubed plus 2 squared plus 4 times 2, right? I substituted 2. Minus, substitute 1, it's going to be 1 over, just 1 cube, plus 1 squared plus 4 times 1, close. Okay, let's see. 2 cube plus 2 square plus 8, because 4 times 2 is 8, minus 1 plus 1 plus 4. You get 14. Question 8. The area enclosed by the curve y equals 6x squared minus 12x, the x-axis and the lines x equals 4 is 40 square units. Okay, for this one, I got confused at the start, but basically this curve 6x squared minus 12x, it looks something like this. Okay, so you need to know when does it cross the x-axis. Okay, over here, 6x squared minus 12x. Hey, okay, you need to know the x-intercepts. It's saying between the curve, the x-axis, and the line x equals 4. This is the curve. This is the x-axis. The line x equals 4 is over here. So we want the shaded area between the curve, the x-axis, and the line. So we want the shaded area. So, okay, we have the end bound is 4. What's the starting bound? We need to know what it is. When does this curve cut the x-axis? Let's see. 6x squared minus 12x. When does it equal to 0? If you solve this equation, take 6x out, you're going to have x minus 2 left. You're going to get two solutions, x equals 0 and x equals 2. Obviously, we want the one that's closer to the 4. So we're going to take 2. Okay, so we're going to integrate from 2 to 4, 6x squared minus 12x. Okay, integrate, you're going to get 6 over 3 to 6 over 3 x cubed minus 12x squared over 2. So you're going to get 2x cubed minus 6x squared. Okay, this is the integrated function. Our bounds are 2 and 4. Put 4, 2 times 4 cubed minus 6 times 4 squared minus, هلا حط ال 2. 2 times 2 cubed minus 6 times 2 squared. Okay. 2 times 4 cubed minus 6 times 4 squared. Minus 2 times 2 cubed minus 6 times 2 square, you get 40. Okay. The curve C of equation 5x squared x squared minus 9 shown below. The area enclosed by the curve C, the x-axis and the lines x equals minus 3 and x equals 3 is what? Okay, just before I go to this, if it helps you, try and graph. Okay, if you're able to graph. If not, you need to always know the bounds. And when you're talking about the x-axis, to find the bounds, you always equate to 0. Okay, equate to 0. And usually, if they tell you x equals 4, that means x equals 4 is one of your bounds. Okay, let's see here. Between minus 3 and 3. So we want this shaded area. Okay, there's actually two ways to do this. Since this, actually no, I'm not going to tell you the second way. I'll do the normal way we do. This way over here, to find the shaded region, we need to integrate. It's 5x squared minus 9. So obviously we have to distribute. It's going to become 5x to the power 4 minus 45x squared. Okay, we need to integrate this, right? Integral is going to become 5x5 over 5 minus 45x3 over 3. This is going to become x5 minus 15x3, right? In between, we can't go from minus 3 to 3, we have to go from minus 3 to 0, then 0 to 3, right? So let's actually start from minus 3 to 0. Substitute 0, you get 0. So let's substitute minus 3, it's going to become minus 3 to the power of 5 minus 15 minus 3 to the power of 3, okay? Remember, when you substitute 0, this is a common mistake I always make. Substitute 0, I get 0. Remember, we're subtracting the upper bound minus the lower bound. So, like what I'd usually do here is I'm going to just get this answer. Okay, which is wrong. I have to put 0 minus this, right? Because you substitute 0, you get 0. Subtracted by the lower bound, I have to put this minus. I forgot to put it now. Don't make the same mistake as I do. So this is from 0 to, from minus 3 to 0. Let's do it. It's going to become minus. Okay, minus. You have minus 3, 5. Minus 15 minus 3, 3. 648. Okay. I don't know where I stopped. I paused the recording, but I put 0 minus and then I did this, right? 0 minus, and I should close the bracket. So the minus should be distributed into it all. Okay? Not all of it. Okay, so minus, and you have into the bracket minus 3 to the power of 5, minus 15, minus 3 to the power of 3. Okay, so you get minus 162. Remember, you make it positive. So this is 162. Logically, if you do times 2, you should get the correct answer, but you don't know that it's symmetrical, so let's actually do it, okay? From 0 to 3. Same thing from 0 to 3. x5 minus 15 x cubed from 0 till 3. Okay, substitute 3, you're going to get 3, 5 minus 15, 3, 3. 3, 5 minus 15, 3 to the power of 3. You're going to get, again, minus 162, so it's going to be equal to 162. Why I skipped 0? Because substitute 0, you're going to get 0. So you have 162 here, 162 here. Add them up, you get 324. Okay? The area of the region by 2x squared plus 1 minus 2x plus 1 is k units. How much is it? Okay, so you have two curves, right? What do? You do integral 2x squared plus 1 minus the other curve, minus 2x plus 1. Okay, dx. So, distribute the minus, going to be 2x squared plus 1 minus 2x, so it's going to be plus 2x, and minus 1. Integral from, again, we don't know our bounds yet. Okay, let's integrate it and then we'll find our bounds here. 1 and 1 cancel, so you're going to get 2x squared plus 2x. Integrate, it's going to be 2 over 3x cubed, and then 2 over 2x squared. Okay, this cancels. So your bounds, we need to find them. How do you know your bounds when you have two curves? Always you do y is equal to y. Okay, you need to see your points of intersection. So 2x squared plus 1 is equal to minus 2x plus 1. Always, whenever you have two curves, to find the bounds, you find their intersection. So you take 2x minus 2x plus 1 here. You can get 2x squared plus 2x, and then the ones cancel. Okay, equals to 0. Now take 2x outside, you're going to get x plus 1. So you're going to get two solutions, x equals 0 and x is equal to minus 1. Two solutions. So your bounds are what? Minus 1 and 0. Okay, substitute 0, you get 0. So you can put 0 minus, open bracket, minus, 2 over 3 minus 1 cube plus minus 1 squared. Remember, put the negative 1 under the brackets. Yeah, also our mistakes, they're so stupid. Wallah, you're forgetting to put, I'm forgetting to put مثلا a negative under the brackets. Shitty mistakes. Really haram to get these things wrong. Minus 1 squared. Okay, you get minus 1 over 3. What do? We make it positive, so it comes 1 over 3. Okay, question 11. Given f of x is equal to this, what's f of 6 minus f of 3? Oh my god. Okay, let's integrate fast. 120 x to the minus 2, right? Because we take it up. Integrate this 120 down, x down, add 1 over new coefficient. So it's going to be minus 120 over x, and between 6 and 3. Substitute 6, substitute 3. I'm not going to do it. Let's see, you know how to do it. So you're going to get 20. Question 12. The process of finding the set of antiderivatives is called integral. Okay. Question 13. Integral 16x cubed is equal to what? 16 down, x down, add 1 to the power, divide by new power, so you're going to get 4x to the power 4, and of course it's indefinite, so you put plus c. Okay. Question 14. Given f of x dx is 10x plus c, then 8 f of x dx is going to be what? Obviously, if you're multiplying it by 8, and it's just going to be 80x. Question 15. You know, they're gonna be done before 7:45. Integral 6 dx. Oh my god, it's 6x, guys. Question 16. Integral 21 root x dx is okay. They want to just integrate. Okay, integrate this. It's gonna be 21 x to the half, right? Because it's a root. take your 21 down, add 1 to the power, it becomes 3 over 2, divide by a new power 3 over 2. Denominator goes, you can do something on your calculators. I'm going to do it in my head. 21. So you're going to get wait, you're going to get 14. Sorry, you're going to get 14. You get 21 divided by 7 times 2, 14, x to the power of 3 over 2. And they kept it in terms of n, like they didn't put a root. They actually, like, they told you to what's the value of the power. If they gave you root, then that would be different. So your a is 14, and then your x is 3 over, and the power of x is 3 over 2. Question 17. Given f of x dx is 10x plus c, g of x dx is 50x plus c, then f of x plus gx integral, oh my god, add 10 and 50, guys, you get 60. I'm not complaining about these questions, well, it saves me time. Integral of this, okay, 8 down, add 1 to the power, divide by the new power. 6x down, add 1 to the power, divide by the new power. 4 down, you add an x. 8 with 4, 2. 6 with 3, 2. Okay, and then you get the rest. Obviously plus c, huh? Don't forget your constant of integration. Question 19. A curve that passes through 3, 0 and has its gradient at xy given by dy over dx equals 3x squared minus 1. What is the curve? Okay, obviously, if you have the derivative, you want the curve, you need to integrate. To go from derivative to normal curve, you need to integrate. So integrate 3x squared minus 1. I'm not going to write it. Integrate 3x squared minus 1. Take the 3x down, add 1 to the power, divide by the power. Minus 1 integrated becomes minus 1x. 3 with 3 cancels, you're going to get x cubed minus x plus c. They told you it passes through 3, 0 because they want you to find the c. So substitute 3 cube minus 3 plus c. What's my y when I substitute 3? It should be 0. Okay, so you're going to get 27. You're going to see equals minus 24. Okay, if you solve this equation. So we're going to go back here. That means our equation is going to be y is equal to x cubed minus x plus c, which is minus 24. X cubed minus x minus 24. Question 20. Fill in the blanks. Integrate this. What do we do when you have an integral with a more than one term under the power? You have to use u substitution. So set u as what's under the power, x squared minus 1. Find du. We know du is always equal to the derivative u prime dx, right? I'm just re-explaining because it's been a long time since we've done these. So u prime dx. So you derive this 2x dx, right? You always remember that you're trying to find an expression for dx. So what's dx? You have to take 2x to the other side. So it's going to be du over 2x. So we go here now. Let's substitute. Integral 5x. We're replacing x squared minus 1 with u to the power of 8. dx we said is du over 2x. X with x. 5 over 2, we're going to take it outside. Okay, we're going to take it outside. And now we can just integrate u to the power of 8. How do you integrate u to the power of 8? It becomes u to the power of 9 divided by the new power. Right? So you're going to get 5 over 18 u to the power of 9. But u is... remember, you have to change u back to its original form. X squared minus 1, so it's going to be 5 over 18. X squared minus 1 to the power of 9. Over here. Question 21. Inshallah, they're nice, petite, easy questions. Integrate this. You can take minus 8 down. X. Add 1 to the power, minus 2 over minus 2. This cancels. You can get 4 over x squared. Or they kept the power up, so you keep it as x minus 2. Okay? Question 22. Given that the particle is moving along a straight line has, oh, I hate this question. Acceleration is 3t squared plus 2t. If the particle is instantaneously at rest at x equals 2 and t equals 1, what is displacement? Okay, they're saying at x equals 2, that means x equals 2, v equals 0, and then t equals 1, v also equals 0. Okay. Remember, x, v, a. Derive. How if you want to go back, you have to integrate, right? Integrate, and let's put prime. Okay. To go to velocity, let's integrate 3t squared plus 2t. It's going to be 3. Add 1 to the power, divide by the power. Cancel. 2t. Add 1 to the power, divide by the power. Cancel. So you're going to get t cubed plus t squared plus c. This is my velocity. Right? We found velocity. Remember, we're looking for displacement. We need the c to continue. How do you find the c? They told us that at time is equal to 1 second, v is equal to 0. So if you substitute 1 cubed plus 1 squared plus c, we're going to get how much as the velocity 0. So you're going to get 2 plus c is equal to 0. So you get c is equal to negative 2. Okay, so معناتها our velocity is actually t cubed plus t squared minus 2. Okay. Integrate again. Remember, we're looking for x. Integrate this again. It's going to be t to the power 4 over 4 plus t cube over 3 minus 2t. Again, you have plus c. We know that at t equals at x equals 2 and at t equals 1, sorry, v equals 0, and we said x equals 2. Okay, x equals 2, t equals 1. Okay, so if you substitute now 1 to the power 4 over 4 plus 1 to the power 3 over 3 minus 2 times 1 plus c, we're going to get how much? We're going to get 2. Okay, so you do this on your calculator. 1 to the power 4 over 4 is just 1 over 4 plus 1 over 3 minus 2 plus c equals 2. So you're going to get this. How much is this? Okay, and then 2 plus 2, it was minus. Take it to the other side, you have to add it. So 2 minus, you get 41 over 12. I'm just solving equations. So we're going to get c is 41 over 12. So rewrite this. You're going to get t to the power 4 over 4 plus t to the power 3 over 3 minus 2t plus c, which is 41 over 12. And then replace your values. Okay. Yalla. 2 more questions left. Question 23. I feel like I did this before. I don't know. I'll just do it anyway. Integrate this 120x to the power minus 4, right? Take it up. Integrate 120x down, add 1 to the power, divide by new power. You're going to get minus 40x to the power of minus 3. Very easy. Plus c, of course. Question 24. 49x squared root x dx is equal to, integrated 49 x squared root x. So it's going to be x squared root x is x squared times x half, right? 2 plus 1 over 2 is 5 over 2. So it's 49 x 5 over 2. We're integrating this, right? Type, you're going to take 49 down. You can take x down. You're going to take 7 over 2 down because you add 1 to the power. Divide now by 7 over 2. 49 is 7. 7 times 2 is going to be 14. And then x 7 over 2. But they kept it as a root. So 7 over 2 is the same as saying root x7. x7 can be written as x6 times x, right? So you're going to take x6 out, divide by 2 is going to be x cubed root x. Other people do it like this. 7 divided by 2 as a mixed fraction is 3, 1 over 2. So it's actually the same as saying x cubed times x half, right? So it's going to be x cubed root x. Other people simplify it like this. Okay, whatever you want. So they're not asking about the power, they're just asking about the constant coefficient. Okay, thank you so much for watching, and good luck in your CA.